The night of March 22nd, 1945. Along a moonlit stretch of the Rhine River near the German town of Oppenheim, Obergefreiter Klaus Hartmann crouched in his foxhole, scanning the western bank through the darkness. He'd been told to watch for American bridging equipment, the massive steel contraptions that would take days to assemble. His orders were clear. Report any sign of pontoon columns, those long convoys of heavy trucks hauling solid metal floats that the Americans would need to span the sacred river. But Hartmann wasn't worried. The Rhine was over 300 meters wide here, with currents running swift and cold from the spring melt. Every German soldier had been taught the same lesson since childhood. The Rhine was Germany's greatest natural fortress, unconquerable without bridges. And bridges took time. Time the Americans didn't have, not with every German gun along the eastern bank already aimed at the likely crossing points. What Hartmann didn't, what German intelligence had catastrophically failed to understand, was that at that very moment, less than 2 kilometers away, American engineers were unloading something the Germans had seen before but never taken seriously. They weren't steel. They weren't even rigid. They were rubber. Massive, inflatable pontoons that could be rolled up, transported by ordinary trucks, and assembled with shocking speed. The Germans had dismissed them in intelligence reports as emergency equipment, suitable perhaps for small streams, but utterly inadequate for a river as mighty as the Rhine. They called them pneumatic floats, and in less than 11 hours, they would carry an entire American army across Germany's last natural barrier, shattering not just a defensive line, but 2,000 years of military certainty. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. For the men of the 249th Engineer Combat Battalion, the Rhine crossing had been weeks in preparation. But for the German High Command, it represented an inconceivable nightmare that they'd assured themselves could never happen. Their failure began not on the riverbank, but in the sterile offices of military intelligence, where analysts had fundamentally misread American engineering philosophy. The reports had come in from France and Belgium throughout late 1944 and early 1945. American engineers were using inflatable rubber pontoons, massive sausage-shaped floats that supported temporary bridges. Wehrmacht intelligence officers, steeped in a tradition of precisely engineered steel pontoons and beautifully crafted bridging equipment, filed these reports away with barely concealed contempt. The consensus was clear. These were makeshift devices, proof of American industrial improvisation, but hardly suitable for serious military operations. One captured, German intelligence summary, recovered after the war, described the American M2 treadway system as pneumatisch not behelf, emergency pneumatic expedients, suitable only for minor water obstacles. The report noted that the inflatable components appeared fragile, vulnerable to small arms fire, and incapable of supporting heavy military traffic for extended periods. What the Germans never grasped was that this supposed weakness was actually the system's greatest strength. The M2 treadway bridge system was a marvel of practical American engineering. At its heart were pneumatic floats, massive rubber pontoons that measured 33 feet long and 8 feet wide when fully inflated. But here was the revolutionary part. When deflated and rolled up, each float was just 4 feet long and less than 4 feet in diameter. A single 6-ton Brockway truck could carry 2 of these floats, plus the steel treadway sections and saddles needed to create 30 feet of functioning bridge. Compare this to the German system. Their standard pontoon was solid, steel or wood, sturdy and reliable, but each one required a dedicated heavy trailer for transport. A German pontoon company might stretch for miles along a road, vulnerable to air attack, impossible to conceal, and taking hours just to move into position. The American system could be transported by ordinary trucks, hidden in forests, and deployed with stunning speed. The creation of these pneumatic pontoons hadn't come from some brilliant stroke of military genius, but from the unglamorous reality of industrial problem-solving. In 1942, as American forces prepared for amphibious operations, engineers recognized a simple truth. Steel pontoons were too heavy, too slow to deploy, and required too much specialized equipment. What if, they asked, pontoons could be made of rubber, inflated on site, and supported by standardized steel treadways that any truck could carry? The result was tested extensively on American rivers, from the wide Missouri to the swift-flowing Susquehanna. Engineers discovered something remarkable. These rubber pontoons, when properly inflated to the correct pressure, could support extraordinary weight. A single M2 treadway bridge, supported by pneumatic floats spaced just 12 feet apart, could carry 40-ton Sherman tanks, heavy artillery pieces, and endless streams of trucks. The rubber absorbed shock, flexed with the current, and proved far more resistant to damage than anyone expected. Small arms fire might puncture a float, but each pontoon was divided into multiple air chambers. Even with several chambers deflated, the bridge remained functional. By early 1945, American engineers had perfected the system. Each pneumatic float came with its own inflation equipment, powered by Leroy compressors mounted on GMC trucks. A skilled crew could inflate a pontoon in under 15 minutes. The steel treadways, each 15 feet long, with raised edges forming dual tracks for vehicles, connected with simple pins. No welding, no complex assembly, just mechanical connections that worked even in darkness, even under fire. German intelligence had observed all of this. They'd seen these bridges in France, watched American engineers assemble them across the Moselle, the Saar, even smaller tributaries of the Rhine itself. But they'd made a fatal assumption. They believed these were temporary expedients, bridges that would be replaced by proper steel structures as soon as possible. They never imagined that the Americans would trust these rubber pontoons for the most important river crossing of the war. The man who would prove them wrong was Lieutenant General George S. Patton, commander of the U.S. Third Army. Patton had been racing across France and Germany with one singular obsession: beat British Field Marshal Bernard Montgomery across the Rhine. Montgomery, meticulous and cautious, was planning Operation Plunder, a massive, set-piece crossing for late March that would involve over 1 million troops, 5,000 artillery pieces, and an airborne assault larger than D-Day itself. It would be methodical, overwhelming, and according to Montgomery, inevitable. Patton found the entire concept offensive. While Montgomery prepared his grand operation, Patton's forces reached the Rhine in early March and immediately began probing for weakness. He found it near the towns of Oppenheim and Nierstein, small communities roughly 15 kilometers south of Mainz. The terrain here was favorable, with high ground on the western bank providing excellent observation and artillery positions. More importantly, German resistance appeared thin, disorganized, exhausted from months of retreat. On March 21st, Patton met with his chief engineer, Brigadier General John Conklin, and laid out his audacious plan. They would cross the Rhine that very night, more than 24 hours before Montgomery's massive operation. There would be no preliminary bombardment to alert the enemy, no weeks of preparation, just assault boats to get infantry across, followed immediately by the engineers with their pneumatic pontoons and treadway sections. Conklin assured Patton it could be done. The 249th Engineer Combat Battalion, along with supporting units, had been training for exactly this scenario. They had over 90 pneumatic floats ready, enough steel treadway sections to span the Rhine multiple times, and most critically, they had speed. Conklin estimated they could have a functioning bridge across the river in 12 to 15 hours, maybe less if everything went smoothly. Patton called his superior, General Omar Bradley, and received perhaps the most perfect order any aggressive commander could hope for. Take the Rhine on the run. No elaborate planning, no coordination with other armies, just go. Bradley understood what Patton intended, to steal Montgomery's thunder and prove that American audacity could accomplish what British caution required weeks to prepare. But for this audacity to work, everything depended on the engineers and their supposedly inadequate rubber pontoons. The 249th Engineer Combat Battalion was commanded by Colonel John K. Addison, a West Point graduate who'd led his men through the Battle of the Bulge just months earlier. His soldiers were veterans, exhausted but experienced, and they understood the magnitude of what they were about to attempt. On the afternoon of March 22nd, Addison assembled his company commanders and laid out the operation. Company K of the 5th Infantry Division's 11th Regiment would cross first in assault boats, securing the eastern bank. Once they established a foothold, the engineers would move. Their mission: construct a 366-metre pontoon bridge from Nierstein on the western bank to the eastern shore near Treadway. Completion time: before dawn. Speed was everything. The longer they took, the more time German artillery would have to target them. The engineers began moving their equipment to the riverbank as darkness fell. Each Brockway truck carried its carefully organised load: 2 rolled-up pneumatic floats, 2 steel saddles to connect the floats to the treadways, 4 15-foot treadway sections. Behind them came the Leroy compressor trucks, the power utility boats with outboard motors for manoeuvring pontoons into position, and the specialised equipment needed for anchoring the bridge against the Rhine's powerful current. Across the river, Obergefreiter Hartmann and his fellow soldiers listened to the distant sounds of activity on the western bank. They could hear engines, the occasional shout, the sounds of an army preparing for something. But in the darkness, they couldn't see the details. They expected the Americans to wait, to mass their forces, to begin with a massive artillery barrage that would give defenders hours of warning. That's how river crossings worked. That's how they'd always worked. At precisely 2200 hours, 10 o'clock in the evening, the first American assault boats slipped into the Rhine. Soldiers of Company K paddled through the moonlit water, expecting German fire at any moment, but the eastern bank remained eerily quiet. The boats grounded on the far shore, and infantrymen scrambled up the bank, weapons ready. Still nothing. The Germans, thinly spread and exhausted, simply hadn't expected an assault without preparatory bombardment. Within 30 minutes, Company K had established a secure perimeter on the eastern bank. Radio calls went back across the river. The landing zone was clear. Engineers could begin. This was the moment everything hinged on. If the German assessment of American pontoon bridges was correct, if those rubber floats really were inadequate for serious military use, the entire operation would bog down. The infantry would be stranded, vulnerable, cut off once German reinforcements arrived. But if the American engineers were right, if their pneumatic pontoons and treadway system could perform as promised, then in a matter of hours, Patton's entire Third Army could pour across the Rhine, exploiting German weakness before they could react. Colonel Addison gave the order. His engineers, who'd trained for this moment on rivers across France and Belgium, began their work. The first Brockway trucks backed down to the water's edge. Crews unloaded the rolled pneumatic floats, connecting them to the inflation equipment. The Leroy compressors roared to life, and slowly, almost magically in the moonlight, the flat rubber rolls began to inflate, expanding into massive 33-foot-long pontoons. The Germans had assumed these would be fragile, easily damaged. But the engineers handled them with practiced confidence. Each float was constructed of multiple layers of rubberized fabric, reinforced at stress points, and divided into separate air chambers. Even if enemy fire punctured one chamber, the others would keep the pontoon afloat. The inflation took just minutes per float, far faster than maneuvering a heavy steel pontoon into position. As each pneumatic float reached full inflation, work crews attached the steel saddles, U-shaped brackets that connected the float to the treadway sections. Then came the most critical part, floating each assembled section into position. Using the power utility boats, small wooden craft with outboard motors, engineers guided each pontoon and treadway unit into the Rhine, connecting them one by one to form a growing bridge extending from the western bank. The current was swift, just as German planners had anticipated, but the engineers had trained for this. They'd practiced on the fast-flowing Meuse River in Belgium, learning how to angle sections against the current, how to use temporary anchors, how to keep the bridge aligned even as the river tried to push it downstream. The rubber, pontoons, flexible and buoyant, absorbed the river's force rather than fighting it. A rigid steel structure might have buckled under the strain. The pneumatic system bent, flexed, and held. By midnight, the bridge extended nearly a quarter of the way across the Rhine. On the eastern bank, infantrymen watched in amazement as the structure grew steadily toward them. Back on the western bank, more trucks arrived, carrying additional pontoons, more treadway sections, supplies for the final assembly. Patton himself arrived, standing on the high ground overlooking the crossing site, binoculars pressed to his eyes. He watched his engineers work with an almost paternal pride. This was it. This was the moment that would end the war in the West. Around 1 o'clock in the morning, the first German shells began to fall. Artillery observers on the eastern bank had finally realized what was happening and called for fire. Explosions erupted in the Rhine, sending up geysers of water that drenched the engineers working frantically on their floating bridge. But the German fire was sporadic, uncoordinated. The defenders had expected crossings at Mainz, 10 kilometers to the north. They'd positioned their heaviest guns there, registered their fields of fire there. This crossing at Nierstein caught them completely unprepared. More critically, the German gunners couldn't believe what they were seeing. Through their optics, in the uncertain moonlight, they watched what appeared to be a bridge materializing out of nothing. Where were the massive steel pontoons? Where were the hours of preparation, the vulnerable build-up that should have given them time to mass their fire? The reports radioing back to division headquarters sounded almost panicked. The Americans were using some kind of inflatable bridge, and it was being assembled at impossible speed. Hauptmann Friedrich Weber commanded the nearest German artillery battery, 4 88mm guns positioned 3 kilometers inland. His orders had been clear: destroy any American bridging attempts. But when the reports came in, he initially didn't believe them. Rubber pontoons, supporting heavy military equipment, across the Rhine? It had to be a reconnaissance party, a feint to draw fire away from the real crossing. He ordered a few ranging shots, but held back his main fire, convinced the actual assault would come elsewhere. That decision would haunt him. By the time Weber realized this was the main effort, the American bridge was already halfway across the Rhine, and his battery found itself receiving counter-battery fire from American artillery on the western bank. The high ground Patton had selected provided perfect observation. American forward observers could see every German gun flash and immediately call in devastating, accurate fire. Weber's battery managed to fire perhaps 20 shells before American 155mm rounds began falling around their positions, forcing them to displace. The engineers working on the bridge barely paused. They'd expected German fire. In fact, they'd trained specifically for working under bombardment. The bridge design itself was remarkably resilient. When a German shell landed close to one pontoon section, shrapnel tore through the rubber, deflating 2 of the float's air chambers. The engineers immediately moved to that section with portable pumps and patches. Within 15 minutes, they'd sealed the punctures and re-inflated the chambers. The bridge never stopped growing. Private First Class Robert Shelado, a combat engineer from Rhode Island, worked through that night inflating and positioning pontoons. Years later, he would recall the surreal quality of the moment. We were building this bridge under moonlight, explosions going off around us, and the whole time I kept thinking about how the Germans probably thought we were crazy. These rubber boats, holding up steel roadways, carrying what would eventually be thousands of tons of equipment. If someone had told me a year earlier that we'd cross the Rhine on inflated pontoons, I'd have thought they were pulling my leg. By 3 o'clock in the morning, the bridge had reached the 3/4 mark. The eastern bank was now clearly visible, and infantrymen from Company K waded into the shallows to help guide the final sections into place. The connection between pontoon and treadway, pontoon and shore, required precise alignment. Too much stress on any single joint could cause failure, but the American system, tested and refined over months of combat engineering, worked flawlessly. The steel treadways, each with their raised dual tracks, locked together with simple pins that could be installed even with cold, wet hands. No complex tools required, no welding, nothing that couldn't be done in darkness under fire. This was democratic engineering at its finest, designed so that any trained soldier could assemble it, maintain it, repair it. Compare this to the German pontoon systems, which required specialized crews, specific tools, and hours of preparation. At 04:30 in the morning, just 6.5 hours after the first pontoon entered the water, the final treadway section locked into place on the eastern bank. The bridge was complete. 366 meters of floating roadway, supported entirely by inflatable rubber pontoons that German intelligence had dismissed as inadequate. Colonel Addison walked the length of the bridge, testing each connection, checking the anchoring. Everything held solid. But Patton wasn't satisfied with just completion. He wanted proof, dramatic proof, that would silence any doubts. At 0500 hours, as the first light of dawn began to break over the Rhine, he ordered a Sherman tank forward. Engineers and infantrymen held their breath as the 30-ton vehicle rolled onto the bridge. The pneumatic floats compressed slightly under the weight, the treadways flexed, but the structure held. The tank drove steadily across, its tracks gripping the steel surface, reached the eastern bank, and kept going into Germany. Behind it came another tank, then another, then trucks, artillery pieces, ammunition carriers, an endless stream of American military power flowing across what was supposed to be Germany's impregnable barrier. The bridge, built in less than 11 hours with equipment the Germans had mocked, was not just holding, it was thriving, handling loads that would have challenged a permanent steel structure. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. As morning fully broke on March 23rd, German commanders along the Rhine began to grasp the catastrophe unfolding before them. Radio reports from the Niederrhein sector described an impossible situation. American forces were pouring across the Rhine in division strength, and they were doing it without a conventional bridge. Intelligence officers scrambled to understand what they were seeing. Aerial reconnaissance, when it could penetrate American air superiority, brought back photographs that seemed to defy reason. General Lieutenant Hans Schmidt, commanding the local defense sector, wrote in his log that morning, "The Americans have constructed a bridge at Niederrhein using inflatable components we had previously assessed as suitable only for minor obstacles. Our intelligence evaluation was catastrophically incorrect. The bridge is supporting heavy armor and appears entirely functional. We lack the artillery concentration to destroy it, and American air superiority prevents our bombers from reaching the target." The psychological impact on German defenders was devastating. For weeks, they'd been told to hold the Rhine, that the river would buy them time, that crossing such an obstacle would take the Allies days of preparation and create vulnerable choke points that German forces could counterattack. Instead, they watched American trucks simply drive down to the river, unload rubber boats, blow them up like children's pool toys, and create a functioning military bridge in less time than it took to cook breakfast. Unteroffizier Ernst Vogel, captured the next day, expressed the demoralization perfectly during his interrogation. They crossed the Rhine like it was a creek. We were told the Rhine would stop them, that our engineers said the American pontoons couldn't handle serious loads. Then we watched 40-ton tanks drive across on rubber boats. What else had we been lied to about? But the story of the pneumatic pontoons wasn't just about a single bridge at Nierstein. Within hours of that first crossing, additional bridges were going up at Oppenheim, just downstream. By the evening of March 23rd, American engineers had constructed 2 complete bridges across the Rhine, both using the same pneumatic pontoon and treadway system. Upstream, at Boppard and Sankt Gore, more crossings were underway. The speed and flexibility of the M2 treadway system allowed American forces to cross at multiple points simultaneously, something German defensive doctrine had never anticipated. Traditional steel pontoon bridges required massive logistics trains, took days to assemble, and created obvious targets. The American system could be transported by ordinary trucks, assembled in hours, and redeployed if necessary. German artillery trying to target these bridges found themselves facing a nightmare. By the time they'd registered their guns on one crossing point, another bridge would be functional kilometers away. On March 24th, just 2 days after the initial Nierstein crossing, over 60,000 American troops had crossed the Rhine. Behind them came the vehicles: trucks, tanks, artillery pieces, ammunition carriers, fuel tankers, mobile kitchens, field hospitals, everything an army needed to sustain offensive operations. All of this flowed across. Bridges that German intelligence had assured the High Command were inadequate for serious military use. The numbers tell the story of German miscalculation. A traditional steel pontoon bridge, by German calculations, required approximately 16 hours to construct across the Rhine under ideal conditions, with no enemy interference. The American pneumatic system accomplished the same task in 11 hours, while under sporadic artillery fire. German steel pontoons required specialized heavy transport vehicles, limiting where bridges could be built. American pneumatic pontoons could be carried by standard 6-ton trucks, allowing crossings at any point with basic road access. Most devastatingly, German doctrine assumed that destroying a pontoon bridge required only a few well-placed artillery rounds or bombs. Hit the pontoons, collapse the structure. But the American pneumatic system proved remarkably resilient. Multiple air chambers meant that even punctured floats remained partially functional. The flexible nature of rubber absorbed shock better than rigid steel, and repairs could be made on the spot with patches and portable pumps, equipment every engineer unit carried as standard. Technical Sergeant Anthony Caruso, an engineer who worked on the Nierstein Bridge, remembered one incident that perfectly illustrated this resilience. On the second day, a German fighter managed to strafe the bridge. Bullets stitched right through 3 pontoons. We could hear the air hissing out. Everyone figured we'd have to halt traffic, maybe even close the bridge for repairs. But the pontoons had multiple chambers, see? So even with some deflated, they still had enough buoyancy. We kept traffic moving while a repair crew worked from a boat underneath. Patched the holes, pumped them back up, and the bridge never stopped operating. Try doing that with a steel pontoon that's been hit. The engineering accomplishment at Nierstein caught the attention of Supreme Headquarters Allied Expeditionary Force. General Dwight D. Eisenhower himself sent a message to Patton. The Rhine crossing has exceeded all expectations. Your engineers have demonstrated the effectiveness of American engineering doctrine and equipment. Congratulations on this achievement. But Patton, never one for excessive modesty, wanted to make a point not just militarily but symbolically. On March 23rd, he arrived at the Nierstein Bridge in his command jeep, cameras following. Halfway across, he ordered the vehicle to stop. What happened next became one of the war's most famous photographs. Patton climbed out of his jeep, walked to the edge of the bridge, unzipped his trousers, and urinated into the Rhine. The gesture was crude, quintessentially Patton, and absolutely deliberate. He wanted the Germans to know, wanted the world to know, that their sacred river, their 2,000-year barrier, meant nothing to American engineering and American determination. When he reached the eastern bank, Patton bent down, scooped up a handful of German soil, and proclaimed, "Thus, William the Conqueror," imitating the Norman king's legendary gesture when landing in England. The symbolism wasn't lost on anyone. The Rhine, which Julius Caesar had declared the natural boundary of Roman civilization, which had stopped Napoleon's armies, which had been Germany's psychological defense as much as a physical one, had been crossed in a single night by rubber pontoons the Germans hadn't taken seriously. The message was clear. American industrial ingenuity had rendered German military doctrine obsolete. Behind Patton's theatrical gestures lay a profound truth about the nature of modern warfare. The Germans had approached engineering with craftsmanship, creating beautiful, precisely engineered equipment that required skilled specialists to operate and maintain. The Americans had approached the same problems with mass production philosophy. Make it simple, make it reliable, make thousands of them, and train ordinary soldiers to use them. The pneumatic pontoon epitomized this philosophy. Yes, a German steel pontoon was more robust in isolation, but an American pneumatic float could be produced faster, transported easier, deployed quicker, and repaired simpler. When you multiplied these advantages across an entire army, across hundreds of river crossings, the cumulative effect was overwhelming. Germany could field a handful of perfect steel pontoon bridges, America could field hundreds of good enough pneumatic bridges, and in total war, quantity had its own quality. By March 26, just 4 days after the initial crossing, American engineers had moved over 60,000 military vehicles across the Rhine at Nierstein and Oppenheim. The two bridges operated around the clock, with traffic control maintaining a steady flow in both directions. Wounded soldiers were evacuated west, while ammunition and supplies flowed east. Mobile repair units crossed to establish forward maintenance facilities. Fuel tankers kept the advancing armored divisions supplied. The bridges became highways, arteries feeding the American advance into the heart of Germany. German attempts to destroy these bridges grew increasingly desperate and increasingly futile. Artillery fire proved ineffective against the distributed, flexible structure. The Luftwaffe, already decimated by Allied air superiority, managed only a handful of attacks. On March 25, a German fighter bomber penetrated American defenses and dropped a bomb near the Oppenheim Bridge. It exploded 15 meters from the structure, sending up a massive plume of water. When the spray cleared, the bridge was still there, pontoons bobbing in the waves, completely functional. A captured German pilot, shot down later that day, expressed the hopelessness his comrades felt. We were told to destroy the American bridges. But they're not like our bridges. They're not solid targets you can hit and collapse. Flexible, they're multiple, and they fix damage faster than we can create it. It's like trying to destroy a river by bombing water. The contrast with Montgomery's massive Operation Plunder, which launched on March 23, couldn't have been more stark. Montgomery's operation involved over 1 million troops, 5,000 artillery pieces firing 4 hours of preparatory bombardment, and massive airborne drops. It was thoroughly planned, methodically executed, and ultimately successful. But it took weeks of preparation and announced itself with such obvious build-up that German defenders had days to prepare. Patton's crossing at Nierstein involved no preliminary bombardment, minimal preparation time, and achieved complete surprise. By the time Montgomery's forces crossed the Rhine in strength, Patton's army was already 15 kilometers into Germany, expanding their bridgehead and racing toward Frankfurt. The pneumatic pontoons, dismissed by German intelligence, had accomplished what massive British preparation required weeks to achieve. The human stories from the Rhine crossing capture the magnitude of this engineering triumph. Lieutenant James Morrison, a platoon leader in the 5th Infantry Division, crossed on the Nierstein Bridge at dawn on March 23. He remembered looking down at the river rushing past beneath the treadways, seeing the rubber pontoons flexing with the current, and thinking, "This is crazy. This is brilliant. This is America." Sergeant First Class William Henderson, an engineer, recalled the exhaustion mixed with pride. "We worked 36 hours straight building and maintaining those bridges. Guys were falling asleep standing up, but we knew we were doing something special. The Germans had spent months fortifying the Rhine, and we crossed it in one night with rubber boats and American know-how. When I saw that first tank cross, when I felt the bridge hold solid under 40 tons of steel, I knew we'd won. Not just won, won the whole damn war." For the German forces defending the Rhine, the pneumatic pontoon bridges represented something more than military defeat. They represented the complete failure of their intelligence apparatus, their engineering doctrine, and their understanding of American capabilities. Throughout the war, German propaganda had emphasized American materialism, portraying them as wealthy but soft, capable of producing quantity but not quality. The pneumatic pontoons shattered this narrative. Here was American engineering that was both simple and sophisticated, mass-produced yet highly effective. Oberst Wilhelm Brandt, a German engineer officer captured after the Rhine crossings, was brought to see the American bridges. His post-war interrogation report captures his assessment. The American pontoon bridge system represents a fundamental difference in engineering philosophy. We Germans sought perfection in individual components. The Americans sought sufficiency in mass production. For warfare, especially modern mechanized warfare, their approach proved superior. A perfect bridge that takes a week to build is inferior to an adequate bridge built in 12 hours. The 249th Engineer Combat Battalion received recognition for their achievement. The bridge they'd constructed in 18 hours, under fire, across one of Europe's major rivers, became legendary in U.S. Army engineer history. Decades later, a memorial would be erected at the exact spot where their bridge touched the western bank at Nierstein, commemorating not just military victory but engineering excellence. But perhaps the most telling evidence of the pneumatic pontoon's success came from an unexpected source. After the war, when Allied intelligence officers examined captured German engineering documents, they found plans dated April 1945, just weeks before Germany's surrender, for a German copy of the American pneumatic pontoon system. Even in their final days, German engineers had recognized the superiority of the American design and were attempting to replicate it. The irony was profound. For years, German intelligence had dismissed American pneumatic pontoons as inadequate. By the time they recognized their mistake, it was far too late. The Rhine had been crossed, the heartland of Germany lay open to Allied armies, and the Third Reich was collapsing. The paper pontoons, as some German soldiers derisively called them, had accomplished what centuries of military planners had considered nearly impossible, turning the Rhine from a barrier into a highway. The morning of March 27, 1945, brought a sight that would have seemed impossible just 5 days earlier. From a hilltop observation post overlooking the Rhine, an American logistics officer counted vehicles crossing the pontoon bridges at Nierstein and Oppenheim. In a single hour, he tallied 137 trucks, 23 tanks, 18 artillery pieces, and 42 other military vehicles, all flowing eastward into Germany on bridges supported by inflatable rubber pontoons. By the end of that first week, more than 60,000 military vehicles had crossed the Rhine at Patton's bridgeheads. The logistical achievement was staggering. Each vehicle represented tons of fuel, ammunition, food, medical supplies, and spare parts that needed to cross as well. The pneumatic pontoon bridges handled it all, operating 24 hours a day, with engineer maintenance crews working in shifts to keep the structures functional. The strategic implications rippled across the entire European theatre. With the Rhine barrier breached in multiple locations, German defensive planning collapsed. Field Marshal Gerd von Rundstedt, overall commander of German forces in the West, had based his entire strategy on holding the Rhine until spring, buying time to consolidate defences and potentially negotiate a separate peace with the Western Allies. The rapid American crossings, accomplished with such surprising ease, shattered that hope. In Berlin, the news reached Adolf Hitler's bunker on March 23rd. According to accounts from surviving staff officers, Hitler initially refused to believe the reports. American forces crossing the Rhine in strength after just one night, using inflatable bridges? It had to be Allied propaganda, exaggerated reports meant to spread panic. But as confirmations arrived from multiple sources, as Luftwaffe reconnaissance photographs showed the unmistakable pontoon bridges stretching across the sacred river, Hitler's rage turned to despair. Joseph Goebbels, Hitler's propaganda minister, wrote in his diary on March 25, "The situation in the West has become catastrophic. The Americans have crossed the Rhine at multiple points, using a bridge system our intelligence failed to take seriously. Our last natural barrier is gone, breached by rubber boats our experts dismissed as inadequate. This failure represents not just military defeat, but intellectual bankruptcy." The human cost of the Rhine crossings, while significant, was far lower than pre-operation estimates. Allied planners had anticipated casualties in the thousands, expecting fierce German resistance and costly fighting to establish bridgeheads. Instead, the surprise achieved at Nierstein and Oppenheim, combined with the speed of the pontoon bridge construction, resulted in remarkably light losses. The 5th Infantry Division reported fewer than 40 casualties during the initial crossing and bridge construction. The 249th Engineer Combat Battalion lost 3 men killed and 11 wounded during the entire operation. Compare this to the Battle of Remagen, where the unexpected capture of an intact bridge 2 weeks earlier had cost hundreds of American lives to hold against German counterattacks. The pneumatic pontoon bridges at Nierstein allowed American forces to cross so quickly and in such strength that German counterattacks never materialized in force. By the time German commanders organized a response, the bridgehead was too large, too well supplied, and too heavily reinforced to dislodge. For the engineers who built and maintained these bridges, the success brought both pride and exhaustion. Staff Sergeant Marcus Powell, who worked 48 consecutive hours during the initial crossing and subsequent bridge maintenance, recalled the physical toll. "We were running on coffee, cigarettes, and adrenaline. Guys would finish inflating a pontoon, then just collapse on the riverbank for 10 minutes before getting up to do another one. But we couldn't stop. Every hour we delayed was an hour the infantry had to wait for supplies, for reinforcements, for ammunition. We knew lives depended on us keeping those bridges operational. The maintenance of the pneumatic pontoon bridges required constant vigilance. The Rhine's current was powerful, carrying debris downstream that could damage the structures. Fallen trees, pieces of destroyed German equipment, even the occasional dead horse swept down from upstream battles, all posed threats. Engineer crews stationed along the bridges worked with poles and boats to deflect debris, guide it between pontoons, and ensure nothing struck the vulnerable connection points between treadways. Weather added another challenge. Spring rains increased the Rhine's flow, raising water levels and strengthening currents. The flexible nature of the pneumatic pontoons proved advantageous here as well. Unlike rigid structures that might have buckled under increased water pressure, the rubber floats simply rose with the water level, maintaining their buoyancy and structural integrity. Engineers adjusted anchor lines and monitoring inflation pressure, but the bridges remained operational through conditions that would have closed traditional pontoon structures. The German response evolved from disbelief, desperate improvisation. On March 28th, German frogmen attempted to plant explosives on the Oppenheim Bridge's pontoons. They swam downstream in darkness, carrying limpet mines designed to attach to the rubber floats. But American security had anticipated this threat. Patrol boats with searchlights swept the river constantly, and machine gun nests on both banks maintained overlapping fields of fire. The frogmen were detected before reaching the bridge, and only 2 of the 6 swimmers survived to be captured. The captured frogmen, during interrogation, revealed that German commanders had initially assumed the rubber pontoons would be easily sabotaged. Cut a few pontoons, they reasoned, and the entire bridge would collapse. But reconnaissance had revealed the multiple air chamber design, meaning even damaged pontoons remained partially functional. The Germans simply lacked the resources to mount the kind of sustained sabotage campaign that might have succeeded. On March 30th, 1 week after the initial Nierstein crossing, General Eisenhower himself visited the pontoon bridges. He walked the length of the Nierstein structure, stopping to talk with engineer crews, examining the pneumatic floats and steel treadways. An aide recorded Eisenhower's comments. "This bridge, built in 18 hours with equipment our enemy dismissed as inadequate, represents everything that makes American forces effective: practical engineering, rapid execution, and the courage to try something our enemies thought impossible." Eisenhower ordered that lessons learned from the Rhine crossings be immediately disseminated throughout Allied forces. The pneumatic pontoon system had proven itself beyond any doubt, and future river crossings would emphasize speed and flexibility over elaborate preparation. The success at Nierstein validated American engineering doctrine and provided a template for operations throughout the remainder of the war. The broader strategic impact of the Rhine crossings became apparent within days. With multiple Allied armies across the river, German defensive coherence collapsed entirely. American armored divisions raced eastward, some advancing 50 kilometers in a single day. German units, unable to establish new defensive lines without the Rhine barrier to anchor them, found themselves constantly outflanked, constantly retreating, increasingly demoralized. On April 1st, American forces from the Remagen and Oppenheim bridgeheads linked up, encircling the entire Ruhr industrial region and trapping Field Marshal Walter Model's Army Group B, over 300,000 German soldiers. This catastrophic encirclement was made possible by the speed with which American forces had crossed the Rhine and exploited their bridgeheads. Had the crossings taken days longer, had bridge construction proceeded at the slower pace German intelligence anticipated, Model might have withdrawn his forces and continued organized resistance. Instead, Model found himself trapped. On April 21st, recognizing the hopelessness of his situation, he released his soldiers from their oaths of allegiance and shot himself rather than surrender. The commander who'd been ordered to hold the Rhine had watched his entire defensive strategy collapse when American engineers accomplished in hours what German doctrine insisted required days. The fate of the pneumatic pontoon bridges themselves varied. The original Nierstein Bridge operated continuously until mid-April, when permanent bridge structures and the general Allied advance made it unnecessary. Engineers then disassembled the bridge, loaded the pneumatic floats and treadway sections back onto trucks, and moved them forward to support crossings of the Weser and Elbe rivers. The equipment proved as reusable as it was deployable, another advantage over heavier, more specialized German systems. Some pontoons showed remarkable durability. Technical records indicate that several pneumatic floats used at Nierstein had previously supported bridges across the Moselle, the Saar, and smaller rivers in France and Belgium. Despite months of use, multiple inflations and deflations, and occasional combat damage, These floats remained serviceable through April 1945. The simplicity of their construction, rubber fabric reinforced at stress points, made field repairs straightforward and extended operational life far beyond what German intelligence had predicted. The 249th Engineer Combat Battalion continued operations until Germany's surrender on May 8, 1945. They built bridges, cleared obstacles, established supply routes, and performed the unglamorous but essential work that kept armies moving. But their 18-hour construction of the Nierstein Bridge remained their crowning achievement, the operation that proved American engineering excellence under combat conditions. After the war ended, military analysts on both sides examined the Rhine crossings to understand what had happened and why. German after-action reports revealed a consistent pattern of intelligence failure. Multiple reports had noted American use of pneumatic pontoons, but analysts had consistently underestimated their capabilities. This failure stemmed from fundamental cultural biases about engineering quality versus quantity, craftsmanship versus mass production. A captured German engineering manual from 1944 contained a section on Allied bridging equipment. The entry on American pneumatic pontoons included the dismissive assessment. Rubber construction indicates emergency nature of equipment, unlikely to support sustained heavy traffic or resist combat damage effectively. This single sentence, reflecting deep-seated assumptions about proper engineering, cost Germany dearly when those supposedly inadequate rubber pontoons carried an entire army across the Rhine. American engineers, by contrast, had approached the problem from a completely different direction. They didn't ask, "What's the best possible pontoon?" They asked, "What pontoon can we build quickly, transport easily, deploy rapidly, and produce in the thousands?" The pneumatic float answered all these questions brilliantly, even if it lacked the impressive solidity of a steel pontoon. In war, the adequate solution available immediately beats the perfect solution that arrives too late. The Rhine crossings also highlighted another American advantage: the integration of logistics with tactical operations. German forces had always separated logistics from combat arms, viewing supply as a support function rather than a combat multiplier. American doctrine treated logistics as warfare's foundation. Those pneumatic pontoons, carried forward by ordinary truck companies, maintained by standard engineer battalions, represented logistics as a weapon system. The ability to cross any river quickly meant armies could maintain momentum, exploit breakthroughs, and keep enemies constantly off balance. In the decades after World War II, the pneumatic pontoon became a case study in military engineering programs worldwide. The basic concept, lightweight, inflatable supports for temporary bridges, influenced bridge design through the Cold War and beyond. Modern military bridging systems still incorporate inflatable components, though made with advanced materials far superior to 1945 rubber. But the fundamental principle, that flexibility and rapid deployment often matter more than maximum load capacity, traces directly back to the Rhine crossings of March 1945. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. For the soldiers who lived through those March days, the memories remained vivid for the rest of their lives. Robert Schelado, the last surviving veteran of the Nierstein crossing, returned to Germany in 2017 for the dedication of a memorial at the exact spot where the bridge touched the western bank. Then, 93 years old, Schelado stood before a crowd of Germans and Americans, describing the night his battalion built a bridge the enemy thought impossible. "We were just doing our jobs," Schelado said that day. "But looking back, I realize we were part of something bigger. We proved that American ingenuity, American determination, and American industrial might could overcome any obstacle. The Germans had the Rhine, 2,000 years of history telling them it couldn't be crossed. We had rubber boats and 18 hours, and we won." The memorial at Nierstein features a section of actual pneumatic pontoon, preserved and displayed alongside photographs from the March 1945 crossing. The inscription, in both English and German, reads, "Here, soldiers of the 249th Engineer Combat Battalion constructed a bridge in 18 hours that helped end World War II. Their achievement demonstrated that courage, ingenuity, and practical engineering can overcome any barrier." Standing at that memorial today, you can still see the Rhine flowing past, powerful and wide, the natural barrier that once seemed unconquerable. It's difficult to imagine that 75 years ago, inflatable rubber pontoons supported by steel treadways carried an entire army across this river, accomplishing in hours what military planners thought would take days. But the memorial's pontoon, faded but still intact, provides physical proof of what American engineers achieved. The story of the Rhine crossing resonates because it captures something essential about the American way of war. Not the most elegant solution, not the most technically impressive, but the most practical, the most producible, and ultimately, the most effective. The Germans built beautiful steel pontoons that required specialists to deploy. The Americans built rubber pontoons that any soldier could inflate and use. When the test came, in the cold waters of the Rhine in March 1945, the simple American solution defeated German complexity. For the engineers of the 249th Battalion and their counterparts in other engineer units, the Rhine crossing validated everything they'd trained for. Combat engineering wasn't glamorous. Nobody wrote songs about inflating pontoons or positioning treadways. But without those bridges, Patton's audacious crossing would have stalled, American momentum would have been lost, and the war in Europe might have dragged on for months longer, costing thousands more lives on both sides. In the grand narrative of World War II, the pneumatic pontoon bridges of the Rhine crossing represent a larger truth, that modern warfare rewards industrial efficiency, logistical excellence, and practical innovation as much as martial valor. The German soldier, who fought bravely but lacked supplies, lost to the American soldier, adequately supplied. The German engineer who crafted perfect equipment slowly lost to the American engineer who produced good equipment quickly. The German commander who relied on barriers lost to the American commander who brought the tools to overcome any obstacle. The Rhine, for 2 millennia, had been Germany's shield. Roman legions stopped at its banks. Medieval armies treated it as the boundary of the known world. Napoleon's forces found it a formidable obstacle, but in March 1945, American engineers with rubber pontoons and steel treadways transformed it from a barrier into a highway, from Germany's last hope into just another river to cross on the road to Berlin. Obergefreiter Klaus Hartmann, the German soldier who'd watched the Western Bank on the night of March 22nd, survived the war. In a post-war interview conducted by American historians, he reflected on that night. "I was supposed to watch for American bridging equipment, the big steel pontoons we'd been trained to recognize. Instead, they used rubber boats I didn't understand were dangerous. By the time I realized what was happening, the bridge was half built. I radioed my officers, but they didn't believe me. How could rubber boats support tanks? But they did. Everything we'd been taught, everything we'd been promised about the Rhine, all of it was wrong." Hartmann's story captures the essential tragedy of the German defensive strategy. They'd prepared for the war they expected, defending against the equipment they anticipated, following the doctrine they'd always known. The Americans fought the war that was actually happening, using equipment that worked regardless of whether it was impressive, following doctrine that prioritized results over tradition. When these two approaches collided on the Rhine, the outcome was never in doubt. The German soldiers who mocked American paper pontoons learned a harsh lesson that March. Those despised rubber boats, those supposedly inadequate inflatable floats, carried the army that would conquer the Third Reich. They held tanks, carried artillery, supported supply trucks, and never failed in their essential mission. They were the embodiment of American industrial philosophy. Make it simple, make it reliable, make enough of them, and win the war. In the end, the story of the Rhine crossing isn't just about bridges and engineering. It's about the collision between two different ways of thinking about war, about technology, about what matters when nations fight for survival. The Germans valued perfection, craftsmanship, the beauty of well-engineered solutions. The Americans valued sufficiency, mass production, the pragmatism of solutions that worked, even if they weren't elegant. On the Rhine in March 1945, pragmatism defeated perfection. Inflatable pontoons defeated steel construction. American industrial might, channeled through practical engineering, accomplished what German military tradition could not prevent. And in those cold, fast-flowing waters, supported by rubber boats, the enemy never took seriously. An army crossed a river that was supposed to be uncrossable, and in crossing it, sealed the fate of the Third Reich. The morning after the Nierstein Bridge opened, as American trucks rolled endlessly across the Rhine, a German prisoner stood watching from a detention area on the Western Bank. An American guard, seeing his expression, asked what he was thinking. The German soldier replied simply, "We should have taken your rubber boats more seriously." That sentence, bitter with recognition and regret, epitomizes the entire story. The Germans laughed at American paper pontoons, dismissed them as inadequate, assumed their Rhine fortress was safe. And then, in 11 remarkable hours, American engineers proved that sometimes the most unimpressive equipment, wielded with skill and determination, can achieve the impossible. The Rhine had stood as Germany's barrier for 2,000 years. But American rubber pontoons, mass-produced and democratically designed, turned it into just another river to cross on the road to victory. And in that transformation, in that achievement of practical engineering over historical precedent, lay one of World War II's most profound lessons, that wars are won not just by courage or strategy, but by the industrial and engineering capacity to turn practical ideas into battlefield reality faster and more effectively than your enemy ever imagined possible. The Rhine had stood as Germany's barrier for 2,000 years, but American rubber pontoons, mass-produced and democratically designed, turned it into just another river to cross on the road to victory. And in that transformation, in that achievement of practical engineering over historical precedent, lay one of World War II's most profound lessons, that wars are won not just by courage or strategy, but by the industrial and engineering capacity to turn practical ideas into battlefield reality faster and more effectively than your enemy ever imagined possible. The morning after the Nierstein Bridge opened, as American trucks rolled endlessly across the Rhine, a German prisoner stood watching from a detention area on the western bank. An American guard, seeing his expression, asked what he was thinking. The German soldier replied simply, "We should have taken your rubber boats more seriously." That sentence, bitter with recognition and regret, epitomizes the entire story. The Germans laughed at American paper pontoons, dismissed them as inadequate, assumed their Rhine fortress was safe. And then, in 11 remarkable hours, American engineers proved that sometimes the most unimpressive equipment, wielded with skill and determination, can achieve the impossible. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.